Okay, in this example, we're going to go through the whole set of steps that we need to follow in order to make this thing work. So let's work this out. We have x squared minus 2x is greater than or equal to 2 times the quantity x plus 2. The very first task is to set the inequality to 0. So let's work this out. X squared plus 2x will be greater than or equal to 2x plus 4. So we set it to 0 by subtracting 2x from both sides and subtracting 4 from both sides. And we end up with x squared minus 4 is greater than or equal to 0. Next step, factor. We're going to get x minus 4 minus 2 times x plus 2. Notice one thing I'm not doing right here is I'm not moving 4 over to the other side of this inequality. You never do that. Don't isolate x squared. You can't use the square root property here. The only thing that you can do is to find the factors, take each of the factors and set the zeros for those factors on the number line. So we go through 0. Here's 1. Try that again. Here's 1. Here's 2, here's 3, and so on. And to the left, negative 1, negative 2, negative 3, and so on. And our solution set right here for this particular inequality is to say that when we have x minus 2 times x plus 2 is greater than or equal to 0, the zeros actually occur at x equals 2 and x equals negative 2. So we mark these on the number line to set up our potential solution intervals. In this case, our solution intervals look like there might be one that goes from negative infinity to negative 2. Since it's a greater than or equal to symbol, we'll include that endpoint. We have a possible solution interval from negative 2 to positive 2. And we have a possible solution interval from 2 to positive infinity. So we pick test values from within each of these intervals. So I'm going to test x equals negative 3. And I always go up to my original inequality to test. So I always say, well, let's see what happens with negative 3 squared plus 2 times negative 3. If that's true, it will be greater than or equal to 2 times negative 3 plus 2. Well, in this case, 9 minus 6 should be greater than or equal to 2 times negative 1. And yeah, sure, that's true, right? Because 3 is greater than or equal to negative 2. So this is in our solution set. So right now, we could actually shade in over the number line part of our solution set right now. All of these numbers to the left of negative 2 would be in the solution set. Does it work between negative 2 and positive 2? Well, let's check out x equals 0, which is certainly in this interval. If I take 0 squared plus 2 times 0, it should be greater than or equal to 2 times the quantity 0 plus 2. Was that true? In this case, absolutely not, because 0 is not greater than or equal to 2 times 2. Right? So this is false. And that won't be in our solution set. So we're not going to consider that, but how about the interval that we said from 2 to positive infinity? Well, we'll choose x equals 3. And let's see what happens if we put in x equals 3. 3 squared minus plus 2 times 3 should be greater than or equal to 2 times 3 plus 2. Well, let's see what happens right here. This is 9. This is 6. Should be greater than or equal to 2 times 5. Well, yeah, that's true, right? 9 plus 6, 15 is certainly greater than or equal to 10. So that fits. This is part of our solution set, and so we would shade in this part of our number line. Linear factors, mark the zeros on the number line, determine whether it's true or false, graph the solution on the number line. Let's write the result in interval notation. As an interval, we would say the set from negative infinity to negative 2. And since we're joining two separate parts, we're going to join it with a union with the set from 2 to infinity. Now, if we're using set builder notation, it would be similar, except that we would say the set of all x such that x is less than or equal to negative 2, or, in place of the union, x is greater than or equal to positive 2, and that would be our solution set in the set builder notation. That's it. More to come in the next videos.